In this video, I would like to look at the algorithm for encoding and decoding a Caesar cipher. And before we get started, let's just do a quick review of how a Caesar cipher works. So let's suppose I have this secret message, which is today we attack, and the key is 3. In the case of a Caesar cipher, the key is just how many letters are you shifting each character in the message. So for example, when the key is 3, all of the A's in the message are going to get shifted 3 places over and turn to D's, and all of the B's will get shifted 3 places over and E to be E's, and C's will be F's, D's will be G's, and so on. So the basic, the main algorithm really is we make an empty string. We're going to make a function that takes a message and a number of spaces to shift, and so we make an empty string, and we loop through every character in our message, and then for each character in the message, we append a shifted character to the result, and then we can return the result when we're all done. So now this function is not something that is built into Python. I've got a stub for it up here, but the main part of the algorithm, right, this is the tricky part, is figuring out how to do the shift correctly. So what I've got here are a bunch of test cases for the shift, and we're going to try out several different scenarios before we actually try to encrypt our message and then see if we can decrypt it back. So, all right, so let's start out simple, right? We've got our character here, and what I want to do is look at, we can take advantage of the fact that all of the characters that we're using in our messages can be found on the ASCII table. So if you'll notice, the lowercase letters A through Z are all in the range 97 through 122. So that's going to make things a lot easier for us. So the very first thing I want to do is just get the ASCII. Actually, we'll call it Unicode values because this table does go beyond 127. It's just we're only using this part of it. All right, so I'm going to get the Unicode value for the character. And the way you do that is with the ORD function. All right, so in this case, if we try to find the Unicode value for the letter A, it'll return 97. The Unicode for B will be 98, and so on. Unicode and ASCII are overlap for the first 128 characters. And now we want to shift it. So I'm just going to take my Unicode and I'll plus equals n, which is going to be the amount of the shift. And then I'm going to return, and I need to take this Unicode value and turn it back to a character. So that is the char function. And so the ORD and the char are just inverse functions of each other. So you can see what we did is we took the character, we turned it to a number, we shifted the number, and then we turned that shifted number back into a character. All right, so let's go ahead and uncomment this and test it out. And what I have here, these are the values that we should get, right? A shifted 0 spaces should map back to A because you're not shifting it at all. A shifted 3 spaces should map to D because 97 plus 3 is 100, and that's the D. A shifted 10 spaces, let's see, 97 plus 10 is 107, and that should map to a K. All right, so let's see if this works. And all looks good. Okay, so it works for those cases. So let's try cases dealing with letters towards the end of the alphabet, and we'll shift different amounts now. And so I'm going to uncomment this, and we'll run it. And we have a little bit of a problem, right? So the W shifted 3 places. W, 1, 2, 3 went to Z, so that's good. But the W shifted 4, 5, and 6 spaces did not work. And what we ended up doing was getting out here into characters that were not part of the set of characters we're restricting our message to, so we're not using those. And so what really needed to happen is, like, when you shifted to W 4 spaces, what I want to do is have it 1, 2, 3, 4, have it wrap around. When I shifted to shift W 5 spaces, I'd like it to go 1, 2, 3, 4, 5 and map to the B, and 6 spaces should map to the C. Right? So how do we get it to map around? Well, I can think of my ASCII values here, and I'm just going to do a little scratch work here. And right, so when something shifts to 123, I 123, I want to map that, right? 123 should wrap back around to 97. And if something, if I ever added a shift and the Unicode ended up at 124, I want that to wrap back to 98. 125 should wrap back to 99. 126 should wrap back to 100, and so on. Right? So this is how we want the wraparound to work. And what you can see in every one of these cases, the difference is 26. If I did 123 minus 97, it's 26. 124 minus 98 is 26. Okay, it's always 26. So this means we have a simple adjustment to make. I can just say if Unicode is greater than 122, which is the end, I'll just say Unicode minus equals 26. And so let me get rid of that now. It's not really code. And run it. And let's see, ZABC. So that, right, everything appears to wrap around perfectly. So something I haven't done yet was apply big shifts. So like, what if I had a shift that was 26 or more? So now we're going to wrap around maybe multiple times, and let's see if we can land in the right place. So I'm going to uncomment this, and we'll run it again. And let's see. So the result should have been W. We got the W, but we didn't get the A. We did, something weird happened here. I didn't get the KW or the S, and I got some other letter here. What I think happened here for these 3 blank lines is that my shift function must have mapped to some character that idle can't print using whatever font I have loaded. So, some obscure characters. Anyway, so let's think about what happened here. Let's see, when we wrap around 26, we end up if there's 26 characters in a string, if you count 26, you're going to end up right back where you started. So that makes a lot of sense. But when you wrap around 30, right, what really happens is you go around, like before you get to 30, you wrap around 26 and you end up right back where you started. And then you just go 4 more. So this is really just equivalent to a shift of 4. A shift of 40 is actually equivalent to a shift of 14, because you wrap around 26, you're back where you started, and then you just go 14 more. A shift of 52 is a shift of 0, because you wrap around twice and you're right back where you started. 53 would be a shift of 1. And then if you did a shift of 100, you're going around 3 times, and then you have 22 left over. So this is actually a shift of 22. And so, what we can do to modify this is just change this to a while loop instead of an if, right? If we do an if, it'll check to see if we're over 122 and subtract 26 once. But in some of these cases with the big shifts, even after, if I add 52, even after subtracting 26, I'm not back in range again. So what I can do is just change the logic, and it's now we're saying just keep subtracting 26 until you're finally in that, below 122 or below, which is the range of acceptable values. So let's see if this works. WAKWXS, yes, and everything got the expected results. So now that our shift function seems to work, we should be able to actually start encrypting messages. And so I've got my today we attack, and let's see what it looks like. Okay, and there we go. So that is what today we attack looks like, shifted 3 characters. Now let's suppose we wanted to decrypt the message. We actually don't really, don't really even need to write a decrypt function is essentially the same thing as encrypting. The only difference is the shift is negative instead of positive. So I'm not even going to write a separate decrypt function. I'm just going to try this. I'm just going to say, the decrypted message, we'll just pass the encrypted function in, and we'll do a negative key instead of a positive key. And so, when we add a negative number, we should be shifting the opposite direction, and therefore we should get back where we started. And so let's see. And, it came very close, except for we got an underscore character here, and so it's not quite working. Let's see try it out with some other shifts. Let's try like a shift of 7 and see what happens. And it sort of worked. We got some places where we got back to today we attack like we were supposed to. And, here's the problem. This is controlling, this is checking to see if we go too far past the upper limit of the character set we're using. But we also have to, when we're decrypting, when we're shifting this direction, what ended up happening is some of the characters got shifted down into this range here and didn't get pushed back. And so all we have to do is copy this exact same block of code. And we'll just say, while we're less than 97, if we're too low, then we'll add to the Unicode. And now we can decrypt or encrypt and decrypt, and hopefully we can use any shift we want. So let's use shift 3, and we'll try a big number. Okay, and it always works now. So that is the Caesar cipher encryption, taking advantage of ASCII values. And so if you have any questions with this, let me know. Otherwise, what you should start thinking about is, how could I modify this shift function if we were going to work with other ranges of characters on this table? So perhaps we wanted to use just uppercase letters, or perhaps even we wanted to write a Caesar cipher that could encrypt and decrypt all characters from 32 all the way on to 126. So all 95 typable characters. Think about what you'd have to change in here. All right, that's it. And let me know if you have questions.